Hi, everyone. My name is Jaired Anderson. So I'm with Imperva since 2016. Over that time, I was in the professional services organization, so had a lot of hands-on experience with customers deploying the WAFs. Prior to that, I was a customer of a multitude of different WAFs from different vendors since about 2006. So I've been working with WAFs for quite a while now. And recently this year, made the switch to the sales side of the house.
We're just going to kick off with a quick poll to see where everybody is at the moment. Okay, so the question is, what was the primary driver in your WAF purchase? Okay, that's great. We're about halfway through. We'll give it another little while there. Remember, please go ahead and pop any questions that you have into the chat. We're probably going to take those all at the end. In fact, we will take them all at the end, but feel free to put them into the chat as and when they come to you. I'll be keeping an eye on that there. Okay, we're going to give that a few more minutes. It's, yeah, interesting. Is that what you expected, Jaired?
Yes, yes. I'm happy to see the results there. I will go ahead and get started here. All right, so it looks like many of you already know this. So why do I need a WAF? And overwhelmingly the answer was protection. But we're going to go ahead and cover some of the other areas on why you might need a WAF. The first is visibility. So what you find is when a WAF is deployed, a lot of people are surprised by the amount of traffic they see on their site. Even for sites that are rarely used by their users, you're going to see a lot of scanning traffic, attack traffic, that sort of thing. So even though you may have very few users using it, the bots and scanners are going to find it and they're going to pound away at it. A WAF is also a great tool for providing visibility through layers 3 through 7 of the OSI model. It's slightly unique in that regard. There's some more tools available today that weren't around before that kind of give you some insight into that. The next thing you want to do once you can see all this traffic is you'll want protection against it. And that's where the WAF excels as well. So the type of protections that we offer range from misconfigurations on the server to 0 days to application flaws. We can also implement virtual patching. So if you, this kind of segues into your vulnerability management program, but if you scan your applications before you go live, and maybe you don't have time to fix a vulnerability, maybe you found some cross-site scripting at the last minute, you do have the ability to virtually patch it with a WAF to allow you to deploy and then fix the cross-site scripting on the back end as time permits. So a WAF is also, looking at the third option here, is also a critical component of your vulnerability management program and can be also incorporated into your software development lifecycle. The protection that the WAF offers with the virtual patching and mitigating attacks is definitely a critical component of a VMP. Also with the software development lifecycle, it allows you to have a feedback loop with your developers and open up that relationship, which we're going to talk about later, which is important if you're going to be administering the WAF. But you can share some knowledge with your developers on where you're seeing attacks, targeting specific areas of the application, what you're blocking, those sort of things. And last but not least is compliance. So probably all pretty familiar with compliance needs. So specifically with PCI, now this was in 2017, they called out WAF by name as an ideal component to, or as an ideal security measure. Since then, they've changed the language to be a little more encompassing of some of the other technologies. I'm just going to read it here. The phrasing is slightly different. So there's still a lot of regulations that call for installing an automated technical solution that detects and prevents web-based attacks, which is pretty much a WAF. Now that we've covered why do we need a WAF, and it sounds like from what we saw from the poll results, all of you are already well aware, protection being the number one. now we're going to talk about considerations for deployment. All right, so I'm going to touch briefly on cloud because the SecureSphere WAF Gateway, it's formerly known as SecureSphere, now it's been renamed to just WAF Gateway, can be deployed in the cloud as well in AWS, Azure, and GCP. It's going to be, when we talk about on-prem, you're going to have more to consider just due to the open nature of your on-prem environment. Cloud providers are generally fairly closed in what you're allowed to do and how you can deploy things. So you don't have quite as many options to consider. But when it comes to on-prem, if you're going to deploy WAF, there's a lot of things you have to think about before you even start, or you're not going to have a successful deployment. So the very first thing we need to figure out is what mode do you want to run the WAF in? So with the WAF Gateway, there's 3 modes. There is the bridge mode, which operates at layer 2. It is transparent on the network. And below that, so this is where it's going to get a little confusing, but try to stay with me here. In versions 14 plus, I think it's 14.3, don't quote me on the exact version, there was this concept of Advanced Bridge that was released, and it replaces transparent reverse proxy, which is commonly referred to as TRP. That is a mode that operates on top of bridge mode. So from the platform perspective, it's still operating at layer 2, but there is a transparent reverse proxy that is running on top of bridge mode. So the next mode is reverse proxy. You may know this by the term KRP, or kernel reverse proxy, which is how it was named previously. This was also updated and renamed in the newer versions. It's now referred to as NGRP, or next generation reverse proxy. And the reason why it's called next generation is because there were some changes made under the hood, and now it supports a much wider array of ciphers than KRP did. And last but not least is sniffing mode. So sniffing mode is, as it sounds, so if we're familiar with port sniffing, it's pretty much the same thing. The WAF gateway will essentially hang off of a sniffing port or a tap and just monitor the traffic, monitor a copy of the traffic, if you will. We do still have the ability to block traffic. It's called a blocking port. So one of the interfaces on the WAF can be connected to a switch, and we can still send resets down the network path to block traffic. However, and we'll talk about this a little bit later, there's considerations regarding ciphers, cipher support based on these modes. There's also network considerations, and we'll get into that a little bit deeper on the next slides. And last, but the next thing we need to consider is the location. So you're going to put it in front of the load balancer or behind the load balancer. This is also a very important decision to make. So in most on-prem environments, from what I've seen, at least personally, working with hundreds of customers on the ProServe side of the house, is there's not a load balancer sandwich like you find in the cloud deployments, where you have a load balancer on the front end and you have a load balancer on the back end. Typically, you have one, and you have to choose and decide, okay, do I want the WAF in the front of the load balancer or behind it? Some of the things to keep in mind are your SSL certificates, your IPs that you're going to protect. So if we are in front of the load balancer, we will be populating the server groups with the virtual IPs. So this can be helpful if you're in an environment or a situation where you don't get a lot of heads up from your infrastructure teams on when new servers are deployed, because there could be 2 or 10 real servers behind that VIP. But if you're in front of the load balancer, as long as you have the VIP specified, all 10 of those are being protected, because we're upstream from that, so we're seeing all that traffic. If we're on the backside of the load balancer, you need to maintain all of the real IPs of the web server. One of the benefits of being behind the load balancer is you have the option to offload SSL traffic at the load balancer and not have to maintain certificates on the WAF gateway itself. Also, you have the ability to choose a performance-oriented cipher on the back end. So the front end of your load balancer could be running, let's say, Diffie-Hellman, and on the back end, you could use RSA, which is faster and allows you to take advantage of that in bridge mode. So now that we've covered some of the things that you need to take into consideration, the very first step, which mode, we're going to cover the different types of architecture, how these will look when they're actually deployed. So I will go into my next slide here. So I'm going to briefly cover the cloud architecture. This webinar is over on-prem WAF Gateway, but I just want to make sure you're aware of these other options and how it all works. So on the left, we're looking at a typical GCP or Azure deployment. It's going to be in the blue square is where the WAF gateways reside. And at the top, we see there's a load balancer, and at the bottom, there's a load balancer. But what you hear is the load balancer sandwich. The WAF will be in between those. On the right is an AWS deployment. It's very similar in the blue square there. Load balancer sandwich, load balancer in front, load balancer behind, with some auto scaling groups. So let's go on to on-prem architecture, which is what we're here to talk about. So on the left, we have sniffing. You can see it's in this diagram, it's connected to a span port on a switch. We also have a regular port connected to send the reset traffic for blocking. So it's important to note sniffing mode does have a drawback in that it cannot decrypt Diffie-Hellman ciphers, which are kind of the standard these days. They're used overwhelmingly. Picked up in about the last, I'd say, 3 to 4 years. Pretty much everyone switched over to Diffie-Hellman. So if you're in sniffing mode, you won't be able to decrypt that traffic, so just be aware of that. However, if you do have another device like a Gigamon or something like that, you can send the decrypted traffic to the sniffing gateway, and it will be able to inspect all that traffic. So on the right side, we have the bridge deployment, and the bridge mode operates at layer 2. So it's for the most part invisible on the network. Just think of it as a bump in the wire. There's a connection that goes in, and there's a connection that comes out, and we decrypt the traffic in between and inspect it, and then pass it on to the web server. So one of the benefits of the bridge mode is it's easy to deploy, simple to deploy. It's not terminating the traffic like a proxy would, although you can run TRP on it, but I'll cover that next. It's usually the easiest to get in line because since it's operating at layer 2, you don't have to intentionally route the traffic to the WAF. It's already in line. So it's also important when you go online to consider where on the network this is deployed, because you want to put it in a situation or a place where you see the web traffic, but you want to minimize any non-web traffic that it'll have to pass through. So just to give you a kind of extreme example, in this case, in this diagram, we can see on the right, it's pretty much in front of the web servers. However, you could technically, I wouldn't recommend it, but you can technically deploy a WAF in front of your firewall in layer 2. So I wouldn't recommend it. You're going to see a lot of traffic. The WAF is still going to have to pass that traffic to the other side of the bridge, so it's going to be very intensive. But that's what I mean when I say we want it downstream, closer to the web traffic itself, so that we're not wasting cycles on passing traffic we're not interested in. Okay, so on the next slide, we're going to talk about reverse proxy mode and transparent reverse proxy mode. So the reverse proxy mode can be a 1-arm or 2-arm or 1 leg or 2 leg, depending upon your nomenclature. It's typically a little more involved to deploy because routing is involved in that sense. You have to reconfigure your firewalls to route traffic, or your load balancer to route traffic to the WAF gateway, and also we have to configure the network routing on the WAF itself. The benefits of reverse proxy are the cipher support. So reverse proxy supports the widest array of ciphers, which include Diffie-Hellman. From what I've seen, this is again working in professional services with hundreds of customers over the last roughly 5 years. The most common deployment that I've seen is bridge mode, followed by kernel reverse proxy, followed by sniffing. So that kind of gives you an idea of how quick and easy it is to deploy bridge mode. But that's not to say that bridge mode is without some drawbacks, which is where transparent reverse proxy comes into play. So the RFC for Diffie-Hellman ciphers states that only the terminating party can decrypt the traffic. So as a bridge, we're technically not terminating. We're decrypting the traffic and we're inspecting it, but we're not closing the connection and initiating a new connection on the back end. However, transparent reverse proxy does exactly that. And what's neat about transparent reverse proxy is that the client still believes it's communicating with the server, and the server still believes it's communicating with the client. We do some neat stuff with rewriting in the packets to where they're none the wiser. The benefit of that, as well, is that there's no need to configure your web servers to read the X424 header to see the true client IP. So your web servers are still going to get the true client IP like they normally would. And that's also a good point that when we deploy in reverse proxy mode, the one on the top, since we are terminating the traffic and reinitiating a new connection, if the web server is on the back end or whatever is next, even if it's a load balancer, if it's not configured to read the X424 header, all of the traffic is going to look like it's coming from the reverse proxy IP on the WAF gateway. So that's an important step to take into account and also configure once it's deployed, because appending the X424 header is not on by default. With transparent reverse proxy, that's not a consideration or an issue. So transparent reverse proxy is the answer for Diffie-Hellman ciphers in bridge mode. It will allow you to inspect and see that traffic. I believe we had a poll at this point, Sarah.
So the question here is, which mode do you plan to deploy? And we've got bridge, sniffing, reverse proxy, or undecided. I feel like I need to get some kind of music for this part. Okay, I'm going to finish up this poll, ending 3, 2, 1, and let's share those results. Okay. What do you think, Jaired? Is that what you expected?
Yes, it is. So the audience is 2 for 2 today. kind of what I expected to see on the poll results there.
Awesome.
So as of version 14, and I touched on this a little bit on 2 slides ago, there is advanced bridge mode. And advanced bridge mode was designed to solve some of the limitations with transparent reverse proxy in bridge mode. So the simple way, moving forward with the new nomenclature in version 14, the simple way to remember this is advanced bridge is TRP and KRP is NGRP, or next generation reverse proxy. So what advanced bridge does is it's actually a version of next generation reverse proxy running on top of bridge mode, operating in the same manner that transparent reverse proxy does. So what's exciting about this for version 14 is that means you no longer have to choose your mode based on the cipher sets that you need to support. So a lot of times that would be your deciding factor. If you have a wide range of cipher sets you need to support, you probably want to lean towards KRP. If you have more control over those, whether they're on the load balancer or the web server to restrict those to what we support, then you'd lean towards transparent reverse proxy. Advanced bridge mode solves that problem. You no longer have to choose based on your cipher set. So when you're looking in our documentation, and I don't recall if this has been updated yet, but because you can see the list that's out there now for next generation reverse proxy, the cipher sets that it supports, those are the same cipher sets that advanced bridge mode will support in the version, the 14x versions of the WAF Gateway. So with that, let's go ahead and take some questions.
Okay, the first one that came in was, can you mention or compare this to Rasp?
Rasp. Okay, yeah. So one of the major differences is that a WAF is a network device. Rasp is a piece of software that gets deployed into your application, essentially a DLL. They can do a lot of the similar things, so there's some crossover between the protections that they offer, but there are benefits to both. The best world scenario would be that both are used simultaneously, but I know that's not always possible. So just think of it as a WAF as a network device. You can have multiple gateways deployed, but just for this conversation, let's just think of it as a single entry point into the network that's going to inspect the traffic, where Rasp is going to be a DLL that's deployed into your applications on the web server itself. So on your hosts, a WAF is a network component. So think of it that way.
That's great. Thanks, Jaired. One other one, and the person asking the question wasn't sure if it was out of scope or not, but I'll ask it and you can let us know. From the performance view, is it better in a KRP environment to have an alias per each service configured on a /32, or is it better configuring just one entry for a /24? Does that make sense?
Yes, that's a great question. So what I can tell you is that in the cloud environments such as AWS, Azure, and I believe GCP also, you actually only have one alias due to the restrictions on the way those environments operate, because they're more closed. So I can tell you in the cloud environments, that is your only option, is for a single alias. When it comes to on-prem, I wouldn't think of it so much as performance consideration as I would an administrative overhead consideration. So do you want to configure and maintain, an alias for each site? I mean, if you do have a very high volume site, then it may be best to, or high volume sites may be best to configure multiple aliases. Now that I think about it, because you are going to have a limited amount of ports or connections that we can initiate on the back end. But for the most part, for most people, it's just going to be additional overhead if you configure additional aliases. You're going to have to create additional routing rules. You're going to have to maintain more rules per alias. Another consideration that comes into play is the SSL certificate. So if you have an SSL certificate that can handle everything on that main alias, then that just reduces your administrative burden.
Okay, great. Should we go for one more, Jaired, before we move on to the demo, or would you prefer to move on for now?
Sure, we can answer one more, and then I have one more slide after this, and then we can go on to the demo.
Oh, okay, perfect. So if I have to migrate from 13x to 14.x KRP to NGRP, what performance metrics should I be worried on?
Another great question. So due to the nature of the way NGRP operates, and I'm assuming they're aware of this based on the way they phrase this question, so they probably read the documentation. But there is a little bit of a performance overhead with NGRP due to moving from the kernel space to the user space, which is where the reverse proxy is operating. There is a slight performance penalty, but that's also what allows us to take advantage of the wide Cypher support. So it's a little bit of a give and take. As far as if you're looking for like a mathematical formula, I don't have one of those off the top of my head. From what I've seen, just reading documentation and communication internally, it hasn't been a large concern. If you're going from 13x to 14x, as far as, okay, do I need to add 2 additional gateways now that I'm running 14? That hasn't been a consideration. However, your hardware, we do want to confirm that the hardware that you're running, if you're running a 13x version, maybe you carried that over from a 12x version, is still meets the needs for 14x. So that's in our docs as well. I don't recall what the RAM and processor is off the top of my head, but that's something to always take into consideration. I also can tell you later in the versions of 14, there are more tools available for monitoring performance. So there is that to look forward to. But as far as just a straight, if you're migrating from 13 to 14, what performance metrics should I be worried? Pretty much just look at your CPU and look where you're at today. Is kind of going to be the general indicator.
Okay, that's great. Thanks so much, Jaired. Please feel free to move on with your next slide. We'll keep some of the rest to the end then.
Okay. So this will be the last slide, but this is also very, very important to discuss, especially if you're in a situation where you have not deployed your WAF yet, because I think probably even myself included, when I first started administering WAFs, you underestimate the level of involvement needed to be successful with a WAF deployment and also maintaining the WAF moving forward. So on the left is most likely what most of the attendees today fall into, which is the InfoSec engineering group. That's the group that's going to be the primary owner of the WAF. In a lot of cases, depending upon your organization, you may also be functioning as the TPM/PPM to get the WAF gateway deployed. So you're going to be taking on that role. You're going to be communicating with your business analysts or the application owners. You're going to be communicating with the networking teams to get this actually deployed. You're going to be communicating with your IT teams if you're going to take advantage of virtual deployments. So that's one thing I meant to touch on earlier when I was talking about the modes, but I'll go ahead and cover that now. So when deploying, we can also deploy virtual gateways, leveraging virtual environments and virtual MXs. From what I've seen personally, it's not common to deploy a virtual gateway for WAF environment. It's very common in DAM, but personally, from what I've seen, it's not as common on the WAF side of the house. And the two major reasons for that is one, performance is generally a consideration. Dedicated hardware is definitely the best way to go for performance reasons. And then the second reason is that a lot of VMware environments or VM environments are not in the correct area of the network or within the network path to route the traffic to it, especially if you want to run bridge mode. Now, if you're going to run a reverse proxy, it's a little more easy to get the traffic routed to the virtual environment at that point. So the next group that's going to be involved is your SecOps or your monitoring group. That will generally be the group that's going to be, and again, this is all depends upon the size of your organization. Like I said, if you're in some shops, you may be the InfoSec engineer that's kind of taking on all of these roles. In a larger organization, the responsibilities may be spread out a bit more. So the SecOps and monitoring they're going to be the ones that are reviewing the alerts, looking at the alerts coming in, whether that's coming directly into the SIM, which is generally the phone in a lot of cases, or whether they have access to the console, this WAF Gateway SecureSphere console. Typically, the InfoSec engineers are the ones that are modifying the policies. So they're the ones that are validating false positives. And that's kind of a great segue into the third square here, which is your development team. If you don't have a good relationship with your developers, you want to have one. They're going to be a very important part of this deployment. So moving forward, what you're going to find is you're going to be looking at lots of alerts coming in, and you may not always know, what's good and what's bad. You may have an idea, you may be leaning one way, but you're not going to want to adjust the security policy based on your spidey sense, whether it's tingling or not. So you're going to want to run that past a developer to say, hey, does this make sense what we're seeing here? Is this normal for this application? And when we do that, or when you do that, I highly recommend don't just send them a screenshot, and because when you see this alert console, there's a lot of information, which is great for validating and confirming what you need to do. But if you just send somebody a screenshot with a wall full of information, it's probably going to fall to the bottom of their list, and not going to be too eager to help out. So when this is initially deployed, I recommend reaching out to your developers, whether it's through Zoom or if you're in the office, have a conference, and kind of go over one-on-one. Hey, this is what I'm seeing. This is what this means. This is what we're looking at in this section of the alert to get them familiar. And that'll go a long way to having a successful deployment and ensuring that your protection is the best it can be. Both ways, right? Because you don't want to create a security policy that's too loose, but at the same time, if you do see something that's a false positive, you want it fixed so that it's not affecting your users. So on the fourth square here, we have the application analysts, and you're going to want to make them aware that the WAF is being deployed. A very important part of this is to make sure they know what the error page looks like, so that if there is a false positive, you can be contacted quickly to remedy it. That goes a long way. So we all know web applications are very diverse. Some are running on legacy platforms and code. They may not be in the desirable state. So you're going to find situations where you may need to adjust some security policies to allow those applications to work correctly. That's kind of expected, especially with legacy code. But what's going to be really important once the WAF is deployed is your time to resolve that. You don't want this bubbling all the way up to executive management just because the person that supports the application didn't recognize the WAF error page or know who to contact to get it resolved. So that part is definitely critical. Don't overlook that step. It'll save you a lot of heartache going down the road. And then last but not least, I kind of touched on this earlier, is the IT and the networking groups. Your networking groups are going to be involved usually in your IT when the devices are racked and stacked, when they're actually brought online onto the network, physically connected, the cabling. Your VMware or virtual environment teams may be involved if you choose to deploy virtual devices. With that being said, I don't recall if I mentioned this, but it's common to deploy a virtual MX with physical gateways. And there's nothing wrong with that. It's actually kind of a preferred method. That will give you control over your virtual environment to expand disk space if needed, or RAM or CPUs on the MX. The WAFs themselves are, I think of them as hard-coded. They have defined RAM specs, defined CPU specs, and they're not to be adjusted. But with the MX, you have some room to expand it with CPUs, disk, and RAM. Just kind of, if you're new to deploying this, just kind of get ready for that cross-functional team interaction and teamwork. It's really important that not just only with your developers, but with your networking teams as well, to have a good rapport with them, because this is a device that's going to be directly in their streams that they're not going to have any control and limited to no visibility into. So a lot of people our teams are not going to take kindly to that. So it's going to kind of be the go-to problem, so to speak. So a lot of that can be resolved just by having that relationship with those teams ahead of time. Show them the interface, show them what you can see, show them the visibility that you have, show them the reports that you can pull. It'll help that the WAF is seen as something that can help them and give them visibility, as opposed to just a roadblock that is causing problems with their applications.
Do you want a question while that's loading, Jaired?
Yes.
Okay, we've got, can NGRP or Bridge Mode be used to protect both web traffic and internal application traffic?
Yes, it can. So with Bridge Mode, there are multiple interfaces. Think of a bridge as two ports, two NICs, two NIC interfaces. You're going to have an in and an out, and the WAF is going to come with multiple interfaces. So you can actually run multiple networks through the bridges to protect different areas of the network. So for example, internally and externally. If we deploy an NGRP, that can still be done. It's just going to depend upon your layer 3 routing. So your firewall coming from your DMZ will route or direct traffic to the NGRP server. And then internally, there's typically not a firewall to an internal website, but you can control that through your DNS to point to, again, it depends if you're in front of the load balancer or behind the load balancer, but your internal DNS would point to the VIP either on your load balancer or the VIP alias on the WAF gateway itself.
Is the demo loaded up yet? Or?
Well, as luck would have it, it's being a little finicky right now. We got it with live demo. So I had this up and running before this started to make sure it was ready, and now it's not cooperating.
Oh,
so
that's always one.
I do have a local version I can pull up just to show the interface, but the reason why I wanted to use this environment is because I have some actual alerts that we can take a look at to go over what you're going to see on the alert screen, because that's a place where you're going to spend a lot of time.
Okay. Well, would you like me to send a couple more questions your way while you're working on it, or
yeah, that would be great.
Okay, so one question is Imperva Bridge Mode the same as Adv Bridge Mode? Does that make sense?
Yeah. So Adv Bridge Mode is the advanced bridge mode that is in the 14x plus versions. So think of it. It's not. It is, but it isn't. And I know that sounds confusing. And the reason why is that think of advanced bridge mode as bridge mode with TRP running on top of it, transparent reverse proxy. So advanced bridge mode still operates at layer 2. It's still a pass-through, but we are terminating the traffic at that point so that we can decrypt those Diffie-Hellman ciphers. So it's not necessarily a one-to-one. A one-to-one would be bridge with TRP running on it is the same as advanced bridge mode. Because in 14x, you can still run in what you consider, quote unquote, plain bridge mode if you want. So that's why I say it's not directly, one-to-one. Is that an answer to the question?
Yeah, I think so. Another question. Let me see. Also in TRP, is the cert size still an issue? Has a key limitation size of 1024. If larger, will not decrypt. Our keys are larger than that on the test site and getting WAF block. Does that make sense?
Yes. So I don't want to give you the wrong answer on that one. I would have to double check our documentation. I'm leaning towards yes in advanced bridge mode, but again, I would have to double check on that one on the docs. So actually on docs.imperva.com, there is documentation on the cipher sets and key sizes that are supported for advanced bridge in the version 14x documentation. I just don't recall what it is off the top of my head.
Okay, well, we can follow up on community. I should say, of course, this session will, there's a recording of this session and it will be made available on community. So we'll be sure to follow up with that link to answer that question there. Okay. Do you want me to send another question your way, Jaired?
Yes, I'm going to, send me another question. I have an idea here on how I can get these.
Okay. Your multitasking is being tested here.
Yes, definitely.
Okay, so let me see. Can I upgrade Gateway 2510 version 13. I've picked a really tricky question here. 13.6040 to 14.3 with no problem? Is the CPU and memory okay?
13.6 to 14.3. That's not a straightforward answer, and the reason why I say that is because I don't know the hardware that you're running, how old it is.
Okay.
So if you received your hardware with version 13.x on it, it's likely you already meet the specs. However, if you've upgraded prior to that, let's say you're running 12, 11, and you've been upgrading all along, it's likely the hardware that you have will not meet the specs for 14. If you, again, like I said, if you started with 13 hardware with 13 on it, it's likely that you'll meet 14. And there's a section on the docs that outlines the hardware requirements as well for RAM and CPU and disk space. So if you started with 13 with your hardware, then likely you're not going to have any problems, but always double check the docs.
Okay, that's great. We'll share those links again in the recording so people can check that out. Another question, has the request size limit in ABR been determined or published?
You guys are getting to the good stuff on this. If you're referring to the post limit, I believe. Sorry, I don't see what question you're on here.
Sorry, it's this one here.
That one. Yeah, I believe they're asking about the post size limit. That has been solved, but there are some limitations still. So depending upon how it's been configured, you still need to take that into account. So we'll work with you to, if you're going to go to 14, to make sure we're deployed in a manner that solves that. Because I know that was an issue for a lot of people that were running TRP with Advanced Bridge Mode as well. So yeah, that's definitely, it's been on our radar for a while, and I know there were fixes that were put into place. There were some intermediate fixes as well as some final fixes. It just depends on what version you're on. So yeah, there are some. I will say yes, just with an asterisk, that we'll want to make sure it's configured in such a way that it resolves that issue for you. So this virtual lab remotely is not cooperating, so I'm going to pivot to my local instance here real quick, which unfortunately won't have any alerts, but I can at least cover some of the interface here.
Question 7 there, Jaired. Will we have to manage VLAN on the GUI on the next version?
If you're asking if it sounds like you want to manage it via the command line as opposed to the GUI. The way that's phrased, saying we have to manage on the VLAN. I believe the answer to that is still yes. So for those of you that are familiar with the WAF gateways, there is a command line that can also be accessed on the gateways themselves and on the MX. And there's various commands that can be run. In previous versions of reverse proxy, you actually did configure the routing and the aliases on the command line, and then it was later moved to the UI itself. I believe you can still use the command line. I know I've seen support cases where it has been used to resolve some issues. So I'm not 100% sure on that one, but I would lean towards that you can use the command line if you know the correct commands to run. Usually it's just simpler to use the GUI because it eliminates having to run multiple commands with just a click or two.
And just following up from that, can I use VLAN for many networks behind the WAF?
Can I use a VLAN for many networks behind the WAF? So if we're talking about, I'm assuming this is referring to bridge mode, although it could be a kernel reverse proxy. Yes, so in bridge mode, we don't interfere with the VLAN tagging. So we're going to inspect it and it's going to pass through, just as if we weren't there. With KRP, I believe that works, but I'd have to double check with the reverse proxy modes.
If I'm already in bridge mode, can I easily convert to advanced mode or bridge? Does that make sense? I think that might mean, can you move back and forth in between them, or?
You can. So moving between bridge and advanced bridge is not as simple as moving between TRP and bridge in the previous versions. And the reason why I say that is because there is a slight adjustment you need to make to how the services are configured, the HTTP services, when you move to advanced bridge. And there's, if I remember correctly, there's also some lines we need to paste into the advanced config. So it's still fairly easy. It's just there's a little more steps than just clicking a checkbox like there was in TRP with the previous versions, moving back and forth. All right, so the good news is I did get my local VM up and running here.
Awesome.
Yeah, gotta love the the other lab here. I'm gonna have to follow through on that. You know what? It's Murphy's Law, right? So I had it all up and working for weeks before this, and now that I need to use it, I can't get into it. Okay, so this is the interface for SecureSphere. On the left, this is a site container. So just think of this as nothing more than a folder or a container to hold your sites. So if you want to separate, or I'm sorry, the sites here is a container. So if you want to separate these by region or data center, that's an option. So essentially, this is what you're going to see. This is a brand new installation. I think this is running 14.3 if I remember correctly. So the first thing we need to do is create a server group. And we're just going to name this demo server group. So this is just a local MX. I don't have any gateways connected to this, unfortunately, at the moment. So once the server group is created, we are going to see this little play icon here. What that means is that the server group is running in simulation mode, which is the mode it runs in by default. That means it will inspect the traffic, show you what would have been blocked without actually blocking it. It's also important to note that with the operation mode being controlled at the server group level, you want to kind of plan out how you're going to configure and deploy your server groups. Because you can have multiple applications running underneath this server group, and when you go to active, they all go to active at the same time. There is a limitation of 30 server groups per gateway. I believe that's accurate, and 100 server groups per MX. Now, there's some ways to get around that with large-scale MX, which we won't go into, but just keep that in mind when you're planning out your server groups. Now, it's not going to stop you. There's not a hard limit in the software, but if you start experiencing instability or issues, that's the first thing that's going to be asked of you is to reduce the server group limit to 30. So this is where we're going to configure the actual IPs for what we want to protect. So think of servers, IPs. This is where we define the IPs. Next, what comes after this, which we have to create, we're going to right click on this and we're going to create a service. And we're going to call this demo service. And it's a service, HTTP service. There's lots of options depending upon if you're using our other products or not, like Jam, for example. I'm going to click create. This is the service layer. So this is where the HTTP protocol policies are going to live. This is where we're going to upload the SSL server certificates at this layer. This is where we would define which header to read for exported for, and which header we want to pass as exported for. If you're in proxy modes, kernel reverse for NGRP. This is also where we will configure the error page. So this is where I talked about earlier. Make sure your application analysts know what this looks like. Also, I recommend changing this from the default. And it'll give you the opportunity to make it look more brand friendly with whatever your brand is. So last but not least, which is created for us automatically underneath this, will be the profile layer. So one thing to always remember when creating a profile is make sure you come in here and change the learning settings from all to one of these two options, which works best for you. Usually we go with only URLs with parameters. And the reason why that's important is because the WAF gateways build a profile of your web application. And by default, it's going to be all, so we're going to learn all of the traffic, all your static files. You could have thousands of images, and those are going to be in your profile. We're really not interested in those because they're not accepting inputs for the most part. So there are limitations on the profile sizes, so we want to stay under those. So that's why I say it's important to adjust this setting right from the get-go to make sure it's set. Otherwise, you're going to have to come and clear out the profiles later to get within those limits. So in a nutshell, this is the three layers that this operates at. So we have the server group level. This is where your network policies are going to reside, And we'll see that all of these policies are applied by default. So if we go to the Applied Policies tab, the firewall policy is applied, the network protocol violations policy is applied. You don't have to go in and configure all of this afterwards. Same thing here with the service layer. The correct policies are already going to be applied under the Applied Policies tab. There are additional policies that you can apply. There are hundreds of policies, literally, if we look at the policies page. And unfortunately, I see I'm running out of time here. But I will go into the web profile. All three of these together can be leveraged and used by the correlation engine to determine whether traffic is malicious or whether it's valid. So maybe, I don't know whether it's via, maybe in another webinar, maybe screenshots, who knows. I really wanted to show you guys the alert screen. Unfortunately, the lab was not cooperating today because I know there's a lot of value in the alert screen, and that's where a lot of people are overwhelmed when they initially see it. With that, I know we're right at 1 minute left.
Yeah. Jaired, I'm delighted that I have you in front of all of these people saying that you would do another webinar. Just can we note that, please, for the record? It's been really great. I'm sorry that that your planned alert demonstration didn't quite behave, but we really appreciate all this great information. It's been great, and thanks to everyone for the fantastic questions. It's been such a great session. And any questions that weren't answered, I will do my best to get Jaired to provide some answers, and we will pop those up on community along with the recording of this session. So I just want to thank you all again. Thank you, Jaired, for your time. I really appreciate it. And keep an eye out for the recording of this on community. And yeah, we look forward to seeing you at the next event. Thanks so much, everyone. Bye.
Thanks, everyone.